Welcome back to Started Learning. In this video, we will see the week 5 assignment 5 of advanced computer architecture in Nptel. Without wasting time, let's skip into today's topic. The forward slash of an instruction I0 is defined as a set of instructions that are data dependent on the value by the produced instruction I0. Okay, so option 5 is the correct answer. Consider the following code snippet ID R1, 8, R2. Subtract R4, R1, R3, multiplication of R5, R6 and R7. So here the code is given by using the registers itself. Assume that we have a stream of we have a misprediction while speculating the latency of load instruction, and all these three instructions get squashed. Which of the following instructions will become orphan instructions due to mispredicted load? Orphan instructions in the sense that instructions would not be that will give the that will not give the accurate result. Okay, so here both second and third instructions become the orphan instructions. Okay, then match the following. Non-selective replay is for windows of vulnerability. Delayed selective replay is for poison bit, and then token based replay is for only instructions in the forward slash are marked. So you just map likewise. And then fourth, in the ARF based pipeline design for processors, the committed values stay in the PRF and the temporary, that is non-committed values resides in the ARF. Okay, so the correct option is third one. Consider the following statements. In the ARF based pipeline design, the value of operands are read first and then these are carried along in the pipeline. So this first statement is false. In the PRF based pipeline design, the operand values read from the register file or the bypass networks just before the execution. So S2 is correct. S1 is false and S2 is true. So this is what the correct answer for this fifth question. And then which of the following is the drawback of ARF based pipeline design? So values need to be stored at multiple locations in the pipeline. So this is what the main drawback of the ARF based pipeline design. So option 3 is correct for this. And then seventh question. How can a compiler based optimizations improve performance? Choose the most appropriate option. Reducing the code size, increasing the instruction level parallelism, replacing slow instructions with fast ones. So everything, each and every option are correct. Okay, so these are the optimization to improve the performance of the compiler. Okay, so all the above options are true. So which compiler based optimization does the following code snippet used? So see here int b equals to a star 8, int d equals to c by 4, int d equals to b star 12. So see here for this particular original code, the optimized code is displayed as like this. So this particular code represents the strength reduction. Okay, here the strength of the values are reducing, that's why it's a strength reduction. So which variable is a loop invariant in the following code snippet? So see here loop invariant is nothing but the value of that particular value is what it's need not to be changed during the execution. Okay, so see here when we come to n, a and b, these values are changing, but these I values is constant. So that's why this the loop invariant is I. Which compiler based optimization allows to prevent pipeline stalls when handling multi-cycle raw dependencies? So it is software pipelining. Okay, software pipelining is used for optimization. So this is what the correct answer for 10th question. So thank you.